The discrete cosine transform is a very important block transform, and it can be a bit confusing because it exists many types of the DCT, and each type may have several definitions. So for example, if we take a look at the documentation of the SciPy FFT pack, the DCT documentation, we see that they are offering 4 types of the DCT. They also offer a normalization mode, so it's basically a multiplication by a scaling factor. So they explain here which definition. So there are several definitions of the DCT1. We use the following. So they explain for each type what is the definition they use and what is the normalization mode. So what's the scaling factor they use if you set this normalization mode to ortho. In our case, we are going to use this definition here, which is not defined. There is no inbuilt type, even though it's the type 4 is a different way that we are implementing here. So we see there is this scaling factor square root 2 over n. We can see a shift of 0.5 in the subband index k, in the time index n. We can see this factor here of pi over n, in contrast to a factor of 2 pi over n we've seen in this DFT. So this also will have some implications in terms of the properties of the DCT. We see here the block index m, so we're processing streams, and because we don't have an inbuilt function the way we want, we will adapt the DCT type 3. So we can define the DCT type 4 like this. We initialize, we have we sample up the signal, we take the DCT type 3 with the upsample signal, we use the orthogonal normalization, we multiply it by square root of 2, and we will have what we want. The DCT4, when you multiply by a scaling factor, it can become, the DCT matrix can become orthogonal, and because of the symmetry, the inverse transform becomes exactly like the forward transform, and that's our case. We are having here this orthonormal transform, and we have that the inverse DCT4 is exactly like the forward DCT4, so we can use this definition for both the transform, the DCT4, and the inverse transform of the DCT4. The DCT has a different subband density, so as we are talking about this factor pi over n instead of the 2 pi over n, the frequency distance between two neighboring subbands is only half as much as of the DFT, so the DCT provides twice the subband density when compared to the DFT.